Hello, everybody. How is life in these days? Whether you are enjoying the Corona holidays or not. So, as you know, this is our practical class. But unfortunately, this Corona that forced us to talk about uh, this like that we are having practical. So today, will just talk and just review all our practical work which we have already done in one or two classes. You know, you have seen one video also last time we played that, and in video and in previous lecture, I was talking about the designing on the classroom models. As this is a basic class, here we are not concerned with this that how much the carious lien is damaging the tooth. We are concerned only with this that how to take a normal class 1 cavity. And for that, we have already talked about the black rules of cavity designing. You know, Black, I told you he was a son of a carpenter in 1908. It is not 1980. In 1908, he established some principles for the construction of the tooth. In that, when he was designing all that, he was concerned with the etiology of the dental caries, which was known at that time. But now we have expanded knowledge about the caries lien and all other um, diseases of the tooth. So at that time, he was having a very limited knowledge about the dental caries. So he designed a cavity basing on that knowledge which was available at that time. Then he designed this cavity on the basis of the materials. Which materials were available? At that time, only amalgam was available. And amalgam still enjoying its highest uh, properties while we are discussing about the uh, reproduction or reconstruction of the tooth. It is an ideal material till today, but he designed this cavity only for the amalgam. At that time, no other material like glass, ionomer, or composite or other cements were not available. They designed this cavity or the principles of the cavities on the basis of the histology of the tooth structure which was known at that time. And also he applied some physics principle. Normally we call it in physics that it is a structural mechanics. You know, I also talked in first lecture that he was he was always observing his father how he as a mason and he was working on the building. So he was observing that what he is doing. So when he was making all these principles, he applied all that structural mechanics or the laws of the physics uh, while he was making and designing these cavities. As we know, that uh, this is a constructional work, and uh, first of all, he observed his father that how he's making the map. So we say on which ground he is going to construct. So we say first of all we should know the tooth morphology, then the mapping of that particular or designing of that building is known as the outline form. Then we talked in detail about the resistance form, retention form, and then uh, resistance form mean how that construction is resisting against the earthquake or the winds or the or all that weather uh, uh, effects on the construction. So when we designing a cavity on the tooth, I already told you that we will try to save the tooth. So the chair should be strong enough that he can resist against the forces which are going to apply uh, on 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 the tooth as a result of friction or other form. Retention means how to retain that building onto the surface. So when we talk about the cavity designing, we are concerned with this, that how we are making a cavity into this. Mean how, what is the width of that cavity, what is the designing, but whether the walls are straight or not, whether the floor is straight or not, or on the 90-degree angle. Because you will know, if the floor is not straight, we cannot retain any table, any chair on the floor. So he designed like such that all those principles which uh, we are applying in terms of the building, we are applying in concept that we are concerned with the resistance form, mean we will preserve the good structure so that it should thick enough so that it thick resist against the masticated forces. If we are cutting more and making good structure weak, and that will be there is a chance that it will be broken down. Then, if we are designing the retention form, then we are also concerned with this, that how much material we are using for the construction of the building, whether this material is strong or not. So when we are designing the retention form, we are concerned with this, that what is not structure blood is less than 5 millimeters. So that material which we are using in such a to construction of the structure, it should be above 5 millimeters. And should not be less than 0.5 millimeters. I'm not saying cannot be, but with material then be problem for us. So, students, we review all this. What are the black rules for the cavity preparation, which are the rules only for the amalgam material, and we are designing and digging a cavity onto the plaster models and making a generally class 1 cavity, and the modifications we will talk later on in third year or a final year. So we have the basic principles. One is the tooth morphology, mean uh, the plot on which we are going to design a cavity. So we should be very uh, um, clear about the tooth morphology, where we are designing this cavity. Then the outline form, how we will make the map on the occlusal surface or the proximal surface or any surface of the tooth. Then resistance form, then retention form, convenience form, and all this removal of the disease, extension for prevention, debridement or the toilet of the cavity preparation, and biological form, making a cavity, carving it. It will be in next year classes we will discuss. Here we are concerned only for this, that how to make an outline form and how to dig a cavity onto the tooth structure. And I hope that you have already made somewhat a cavity onto the plaster models. You know, when we were talking about the occlusal surface, we talked about that there are the 4 cusps, and as tooth is made up of 4 lobes, there are the 4 cusps, and every cusp is made up of 4 ridges. One on the occlusal surface, one triangular ridge, and 2 other ridges encircling that particular ridge, and then the 4th one on the buccal side or on the lingual side. So these four, when we are saving all these ridges and designing and making an outline onto the occlusal surface, we know this, that the cavity design will be like a dovetails, that two dovetails are joining together into the center of the tooth. So when we are digging this, we start with the flat or a straight this excavator, and then we are digging this cavity down into this. And I told you that depth of the cavity will be about 1 millimeter down from the dentinoenamel junction. And here we will again estimate it that normally the height of the crown of the posterior molar is 8 millimeter, and we are digging the cavity, and the enamel thickness is 2.5 millimeter on the occlusal surface, 2 to 2.5. And if we are making and digging a cavity on a normal tooth, the depth will be about 3 millimeter, 2.5 or a 3 millimeter. So we will estimate it onto this model which you have in your hands, and we will go down deep accordingly. So we'll make, and the extensions of the buccolingual of these cavities, we talked about this, that it will be extended in the buccal groove or in the lingual groove up to the level where these fissures are converted into the smooth surface. And we all also talked about this, that what are the fissures? Fissures are the defective joints of the enamel, and where two fissure crosses each other on the deeper part of the grooves, that will be a pit. And normally when we say how classify classify this cavity designing, it is a class 1, class 2, class 3, or class 4. Class 1, normally we are defining it that it is a cavity design on the posterior surface, occlusal surface of the posterior teeth, buccal surface, and the lingual surface of the posterior teeth and anterior teeth. Normally, in short, we can say that this is a cavity design for the pits and fissures. Wherever the pits and fissures are present, and we are designing a cavity and involving pits and fissures, mean we are digging a cavity class 1. So we have talked about this, and I review all this for this, that you should you can refresh your knowledge about it. And now today I'm concerned with this class 2 cavity. When I say class 2 cavity, Black divided it into 5 cavities, and 6 1 is we can say that class 1, 2, 3, 4, and we have already talked about it. So in this class, mainly I am concerned with this, how to dig a cavity which is a class 2 cavity, and normally it is on the proximal surfaces of the posterior teeth. So considering first principle of the cavity rule of the cavity design, that is a tooth morphology. So let us discuss about the tooth morphology of the proximal surface of the posterior teeth. If I say, or you look onto the model, you know the cervical line is almost straight. Cervical line is the crown root junction. And look at this, what is a cervical line? Cervical line from buccolingual on proximal surface is almost straight. And then we can look, if we look on the buccal side of this buccal side is curved towards the occlusal surface. So this curve of curvature of the buccal angle is dropping towards the occlusal surface, and on lingual side it is also dropping towards the occlusal surface from the cervical line, but it is almost straight. So if I consider the normal plot of this, we can say the proximal aspect of a molar is wider at the cervical margin and narrow on the occlusal surface. And here we can view the lingual ridge of the mesiolingual cusp and the mesial view or a mesial ridge of the mesiobuccal cusp. So it is the boundaries. If we look onto the boundary and slightly marginal ridge, which is a straight ridge onto the proximal surface, we can view over there. So it is bounded occlusally by the two ridges of the lingual and the buccal cusps, and one in between these two ridges, we can see the straight marginal ridge, marginal buccal marginal ridge or the lingual marginal ridge. Crest of curvature is dropping towards the occlusal surface onto the buccal side, and also dropping towards the occlusal surface on the lingual side. Cervical line is almost straight. So applying the previous principles which we applied for the occlusal surface of the posterior teeth for the class 1 cavity, now we are designing, if we are designing the outline form on the occlusal surface, we'll go with we'll go as for a general principles, we'll go straight with the straight marginal ridges, and we will go around the we'll go around the rounded tuberosities, and we will go straight with the marginal ridges. So it was the normal principles which we applied when we are making the digging a cavity onto the occlusal surface. So here, if we see this surface is almost flat. Normally on the posterior, on the distal buccal surface, we have some sort of fossa in between, in the center of the proximal surface. So if slight fossa is present, mean we have the buccal ridge. On the buccal margin we have one ridge, on the lingual margin we have ridge, there is a cervical line, and the three ridges we can see onto the occlusal surface. Now we will go straight with the straight ridges. If I am digging a cavity, it will be narrower from the upper side, from the closer side, and it will be slightly straight. So as it is wider from the base of this, so it will be a line dropping towards the buccal side on the base, on the cervical margin, and it will be a narrower from the occlusal surface. So it will be a cavity designed like such that the cavity will be narrower from the occlusal surface, then we'll go straight with this straight line of the cervical margin. So it will be like a box, is a sharp box, having a buccal straight wall, having a lingual straight wall, then having this, and we are saving the ridges. We will save the ridge, buccal ridge, we will save the lingual ridge, and we will also save the cervical margin.
Abdullah, what are you doing? Close it.
So cavity design will, the outline form will be the same. ये उनको भी शो हो रही है.
नहीं सर, ये स्टूडेंट है, इसमें कोई और की भी अब्दुल्ला.
So here, you know, if we are approaching this, we'll cut this ridges, the basis of this ridges and the marginal ridge. When we are designing a class 2 cavity here for the amalgam, so when we are designing a cavity for class 2, you know, approach on the proximal surface, because we have the adjacent tooth with that. So we cannot look the proximal surface like such, which I am showing you. So we will approach from the marginal ridge. We'll, so we will involve this marginal ridge mesial or buccal when we are designing the cavity on buccal or a mesial side, and we will go deep up to the cervical margin, and we will save this cervical ridge also, cervical margin ridge, cervical margin, which is almost straight. So we will make the corner round as we have the basic principle that it will be almost round. So now the cavity outline form on the proximal surface is wider from the lower side, from the cervical margin, narrower from the mesial marginal ridge or the distal marginal ridge on the occlusal side, and it will be a straight from the buccal and the lingual aspects. So by designing this, we are saving this buccal ridge, lingual ridge, and we are sacrificing the mesial marginal ridge or the distal marginal ridge because we cannot approach up to this. Here we know this, that as the enamel, it is going down towards the cervical margin, the depth is continuously decreasing, and it will be a very less width of the enamel prisms on the cervical margin. So we will consider the same rule which we are applying for the resistance form of the anterior teeth, that we will go deep up to the 0.5 to 1 millimeter down into the dentin from the dentino-enamel junction. So here normally the width of the cavity on the proximal surface of the width of the enamel is about 1 to 1.5 millimeter. So cavity depth on the proximal surface will be about 1.5 to 2 millimeter. It will be less than the cavity depth of the occlusal surface. So we will go down deep. Here again, when we are designing the cavity or digging the cavity, when we dig it and sacrifice the marginal ridge, and we will make a class 1 cavity on the occlusal surface, that means these two, and considering this proximal surface also as a class 1 cavity and applying all those rules which are rules for the class 1 cavity on the occlusal surface, these two class 1 cavities when joined together, when I'm again repeating it, when these two class 1 cavities join together make a class 2 cavity, and we say that this is a class 2 cavity. And if we look onto this proximal surface, the floor of the cavity will be an axial wall. If we are looking from, it will be a straight axial wall when we are looking from the occlusal surface. So we can look, if we have the class 1 cavity on the occlusal surface and class 2 cavity on the proximal surface, and they are joining together, the floor of class 2 cavity will be the axial wall in this cavity design. It will be a straight and coming upward towards the occlusal surface. And the floor, when we are looking into this, it will be on the cervical margin. When we view from the occlusal surface, the floor will be on the cervical margin. And here, the depth of the floor, you know, at that area, the enamel prisms are only 0.5. And if we are deep 1 millimeter down from the dentino-enamel junction towards the pulpal side, mean the floor will be, dentine and enamel both will be about 1.5 millimeter. And we are making this. And if we look onto this from the occlusal surface, it is going broader and broader down towards the cervical margin. And there will be some undercuts present, a good undercut present when we view from the occlusal surface. And here, again, for the resistance form and for giving the resistance, because when we are filling this cavity with the amalgam, there is a chances of dislodgement of this. So we will give slight undercut. And we are giving the undercut on the occlusal surface with the buccal wall and with the floor. there we were giving a slight undercut. So same undercut we will give with the wall of buccal and a lingual side. Or sometimes we are giving a groove to give some strength to the, so line angle which we make from the axial wall and with the lingual wall and or the buccal or the axial wall will give slight undercut into this, so that filling material which we are filling into this proximal area should not dislodge proximally. So here, I know this, that if I am talking about this, it will be very difficult for the students to, to, uh, to make some idea into their minds about this. So it is very, very important that if we are working into the laboratories and making a cavity like such, will be very easier for us to understand and to dig a cavity onto this surface. But here, unfortunately, because of this corona, we have to talk like this. But one day, inshallah ta'ala, we will be talking about this digging of the cavity on these plaster models in the classroom, and it will be easier for you. We'll repeat it again. But at this time, if you can imagine about this, it will be helpful for us. So you can start digging if you have these models. You start making the cavities on this, and if it is not good, we'll make it good in the classrooms. So it will be a practice. You know, it is very important for the dental surgeons that they should be very good in practical handling if they want to be a good dental surgeon. So practice it. Practice is, if you know how to dig a cavity on these plaster model, then it will be very easy for you to dig a cavity onto the plastic teeth or onto a normal tooth structure. So here we are concerned with this, that how to dig a cavity. So when these all these class 1 and class 2 cavities, that they join together, they make a class 2 cavity, and it will be easy for us. Here, one thing I wanted to share with you, that I normally say that this is a cavity of this may be a cavity of the fissures, pits and fissures. When I say pits and fissures, the pits and fissures are the defective joints. So it will be difficult for us when if it is a pits and fissure cavity, um, very difficult for us to carve it smoothly. So and make a good joint in between the tooth surface and the material. So this is how we are designing this. This is how we are designing it, that we are involving all pits and fissures while designing this. When I say we are making only class 2 cavity, say about disease is only onto the proximal surface, and the occlusal surface is not involved in it. So if we are cutting a part of a fissure on any area of the occlusal surface, mean we cannot carve it and we cannot make a good joint in between the tooth structure and in between this material. If we cannot carve it smoothly, if we cannot make a good smooth joint, mean there will be some pit available on that joint if the fissure is joining with that. And food alignment or any block involvement in that area will again recurrence the disease on that area. So whenever we have a pit and fissure caries, here please note one very basic principle, that we will involve all pits and fissure, all pit and fissure, and we will not leave it. We will make a cavity design up to the level where these fissures are converting into the smooth surface on all the occlusal surface. I don't know whether it is clear to you or not, but one day I will inshallah clear it to you. So when we are making a class 2 design on any tooth structure where there is no involvement of the disease on the occlusal surface, even then we have to make a full class 1 cavity and then joining it with the proximal surface area cavity. So class 2 cavity can't say that it will be completed if until or unless we are not involving all the pits and fissure caries and making a class 1 design onto the occlusal surface which is joined with the class 2 design on the proximal surface. So when making this class 2 mean it is essential for us to make a class 1 because we can't leave any pit or fissure area which is joining with the material on that area where there is a defective joint available on the onto the surface. So this is how we are making this. And here another very important factor. You know, if we are making this occlusal surface, mean there is a floor. The floor is towards the pulpal side and the axial wall is also towards the pulpal side. If we leave this axial angle, mean the angle which is formed by the axial wall of class 2 cavity and the floor of the class 1 cavity, that angle must be beveled, because this is the area where the marginal ridge was present and the maximum forces are applied on that particular area. And if we are not giving a good strength to the material on that area, and strength we can give only by this, that we are making more thickness of the material over there. That means the forces which are applied onto this will break it off. And there will be a crack in between the proximal area and in between the occlusal area. So we will give a beveling of that particular angle, which is a axiopulpal line angle. We call it that this is a axiopulpal line angle. So that should be beveled, and then it is filled with this. When we make it bevel, and there are three shapes of the bevel. We can say that this is a short bevel if we are giving only a very short curve, then a long bevel, and in between long and short is a medium bevel. And it whatever we are beveling that particular axiopulpal line angle, we are considering this, that how much of depth of the cavity on the occlusal surface and on the proximal surface. Normally, when we are digging the cavity on the plaster models, we are giving a medium beveling on that particular area, not a short one, not a long, deep one. So this is how we are designing the class 2 cavity onto the plaster model. Whenever you are starting digging the cavity, start with the straight excavator. Then with right or left, we can make, we have already talked that we will not leave any sharp line angle, because if we are leaving this sharp line angle, it will be difficult for us to condense the material or retain a material into that sharp line angles. So we will normally try to make all line angles or the point angles which are slightly rounded. Slightly rounded. I am not saying it will be a round. There will be a slightly rounded, that there should not be any sharp area into that, because we cannot retain the material and it will affect our retention form, because that material will be loose and the structural material will be loose, and that will be dislodged. So this is how we are designing this cavity into a proximal surface. We'll discuss it again one day in the laboratory, and we will dig a cavity. But here in this class, I'm concerned only with this, that I can give you an idea of class 2 cavity, design of the class 2 cavity. This will be again like such that will look into the tooth morphology of that particular area. Then we'll make a outline form, then how to make a resistance form. These principles are the same when we are designing class 1, 2, 3, 4, or 5. All these 5 principles we considering when we are digging a cavity, and the principles are the same. Normally we can say we'll go around the rounded tuberosity and we'll go straight with the straight elevation, and we'll go deep and make a cavity like such. So here generally we are making and digging a cavity for the amalgam only, but in these days, in Black make these rules in 1809, and it is about 2 centuries past, and the rules are still enjoying their level. Here, let me discuss with you, which is not so essential for you, that what are the requirements of the tooth preparation. One, that dental tissue. This is not a dentinal tissue, on the slide, it is a dental tissue with their structures and properties, and restorative materials. And if I say restorative material, that is only one material in these principles, and that one is the amalgam. And the amalgam properties also plays a very important role. And then the structural mechanics, which are the physics laws. If we say that these are the basic requirement of the tooth preparation, then I want to give you a general idea about it. Uh, the, the, there is some, because we have now the expanded knowledge of pathology, dental pathologies. We have an expanded knowledge of the dental materials, because now we have the very, very advanced material available for the tooth structure. And no doubt in astrology, again, we have very expanded knowledge, and knowledge is now changed and in last decades. And so now there are the requirements. I don't say that principles, they are enjoying their highest point, but there are, and these modification now in these black rules of cavity design, we need, because we have now the knowledge of root caries, because it is not involved in this. We are talking about class 1, 2, 3, 4, 5. In up to 5, we are not talking about the root caries. So it is a modification requirement in the previous rules. Non-carious liens, amelogenesis imperfecta, dentinogenesis imperfecta, or other type of knowledge about dental pathologies. Uh, there are now the requirement. Then latest concepts, etiology of caries, remineralization, mineralization of the enamel. So there are now the expanded knowledge, and we need some modification requirement into this. Then these modern restorative materials also plays a very important role. So think us about the modification in these rules. Or latest knowledge of histology of tooth structure also plays a very important role. So this we will discuss later on. But I want to give you an idea. If anybody is saying that there should be a modification in these rules, but remember one thing about that: the physics rules are not changed. Black depends upon on the structural mechanics, and structural mechanics still is the same one for the constructional work, and we can only apply these rules onto on when we are talking about the construction. So here we are concerned with the rules, black rules of cavity designing, and the classification of the blacks. Next time, inshallah, we will discuss about the class 3 cavity, which is on the anterior proximal surfaces of the anterior teeth. And for that, I will advise you, all of you, please look into the tooth morphology of the proximal surface of the anterior teeth, so that we can discuss on this um, uh, very technical lectures. So we'll talk about this, because um, this is a conceptual lecture, only to clear your concepts about the class 1 or the class 2 cavity. So this is about the class 2 amalgam restoration. So we'll if you have any query about it, so then tell me.